In this video, I'm going to walk through my experience, process, and solutions that I went through when I recently participated in a tiny model hackathon. And this is my second place winning solution. The datasets that we were training on were the TinyStories datasets, and I was in the medium weight class for models, so we could train up to 60 million parameter models. And this is pre-training from scratch, which is something I haven't done before, and this is the first time that I did it. So I'll walk through my process here, show what the kind of final solution was, and then I'll switch to my Colab notebooks and show you what my training script looked like, as well as what my dataset pre-processing script looked like. I'll start with the main theme in this hackathon, which is one of my favorite quotes by Nick Sirianni, head coach of the Super Bowl champion Philadelphia Eagles. "You cannot be great without the greatness of others." And I think this is a great quote to advocate for open source, and it's certainly something that I benefited from and experienced in this hackathon, which you'll see in a second. So the very first thing I did is I did some very quick and dirty experiments, and I just kind of threw things at the wall and kind of getting a sense of get a feel for what works, what doesn't work at a very, very crude level. So I just picked a learning rate. I just picked an architecture, and I just picked a tokenizer, and I slapped it together and did three training runs. I did 500,000 samples, 2 million samples, and 4.9 million samples, where the samples are stories like once upon a time Johnny went to the beach and he saw a dolphin and yada yada. And so the reason I did this first was that I wanted to get a sense of how dependent the model generation quality is on duration of dataset training. So how many tokens it sees, does it really affect it? And obviously the answer is yes. Does the score improve with dataset size? But as I've learned in different Kaggle competitions before, just because you train on more data doesn't mean you get the best model. So I wanted to make sure that made sense, and I verified that. And there was a pretty significant, relatively significant increase from 500,000 to 2 million to 4.9 million samples. So that let me know that, okay, I think I need to schedule my submissions in a way that gives me enough time to train for a longer duration. The first few submissions I did, I had a temperature of 1.5, which I later learned was way too high. And so dropping that down to 0.8 and having a top p-value of 0.95, so restricting the pool of tokens it considers a little bit, was clear increase in my score. And just as a reference, these scores are out of 5 in terms of the LM as a judge that the competition used to grade our tiny story completions. So that was really promising. So I'm like, okay, I can tweak inference parameters, so I should keep some time in my schedule to tweak around and play around with inference parameters, because clearly that makes a significant impact. One of the things we were encouraged to do was train our own tokenizer to get some experience doing that, and also to save some parameters, because we are using a small vocabulary in the dataset because it's meant for 3 to 4-year-old children vocabulary, because these stories are children's stories. So you don't necessarily need like the 50,000 vocab size of the GPT-2, or I think it's the GPT-Neo tokenizer. So the first tokenizer I trained, I knew very little about tokenizer training, and I incorrectly chose a minimum frequency of 2, and I restricted the vocab size to 9984 because I wanted to do a multiple of 64, as Karpathy has mentioned, because of that speeds up the training time. And I used the entire data set, so 4.9 million samples, and a min frequency of 2 was very low for that. And maybe I'm sure there were other things that I didn't do correctly. And this significantly worsened my score. So on a limited time and a limited compute budget, I'm like, okay, not sure if I'm going to be able to experiment too much with tokenizers. And then I went back to my best performing original tokenizer run, and I trained it for 2 epochs, and it actually dropped down to 1.58. So that let me know that the duration of training has a cap, and there are other things that I need to tweak, namely learning rate. So this was done in somewhat of a collaborative way because this was part of a Fast AI study group, and so folks were sharing tips and tricks. And so one of our contestants shared the Improving Hugging Face Training Efficiency Through Packing with Flash Attention blog post, where they talk about how they use the data collator with flattening to introduce sequence packing when you use Flash Attention 2. And this, significantly, you can get like a 2x, 3x speed up in training. So if this hadn't been shared in the group, I probably either wouldn't have been able to compete in the medium class, or I would have probably, fallen to last place, or, just not had a good experience. So credit to the collaborative nature and the open source nature of this hackathon. And that's why I started with that Nick Sirianni quote. We could ask questions, and something that came up was the importance of using the end of stream token. And this was something that I had not done. I only had a BOS token in my tokenized data set. I did not have an EOS token. So this was something that I made a note to definitely implement. So I was searching online for any examples of folks replicating the TinyStories paper and the TinyStories training. And I found a couple, and this one in particular walks through and uses NanoGPT, and I saw that they used a learning rate of 5 eneg4. So this was 5 times the learning rate that I was using. So that let me know, okay, this is something I definitely want to try. And then my biggest breakthrough, which was pure luck, I didn't do anything to, achieve this. And hold on a second, let me go turn off an alarm. I'll be right back. Okay, I'm back. So I searched for TinyStories learning rate, and I saw that Eldon Ronan, the author of the original paper, had published the recipe on the 33 million parameter model card. So that was obviously a huge breakthrough for me. So I'm like, okay, oh my goodness, 20 epochs, right? So I did 2 epochs and the performance worsened. And so I took the learning rate, I took the weight decay, which was 0.1. I was getting the warning that you shouldn't use this weight decay because it's too large, but it worked. So, so many questions on why that works for this training. So that's when I really started to gain traction. Obviously, I felt like I had the answers to the test. So I was using a different data set than the text file that was referenced by the author. And so they used I think it was like a 2 million story data set for 20 epochs, and I had 5 million stories. So I'm like, let me do it for 10 epochs. So my best score went from like 1.98 up to 2.57. So I'm like, okay, now we're cooking. I had lowered my temperature down to 0.6 because I found that would, was giving me a better generation of stories. And then I took the other piece of advice from our study group that you should add the EOS token. So I appended the EOS token to my data set, and I found that that gave me a little more flexibility, so I could increase the temperature a little bit without worsening the generation. So I got some more creativity points, and so that boosted it up to 2.93. I tried using the num return sequences argument during model.gener. That didn't really improve the score. And then I increased my temperature, increased the minimum length, and then my final submission parameters were 20 epochs, temperature of zero point 0.9, top P of zero point 0.5, which was really interesting. I didn't expect that to perform well because I'm only using 50% probability cumulative of the tokens to be considered. And I lowered my temperature to 0.75, and then I increased that top P to 0.85, and that gave me my 3.07 out of 5, which was the best I had done so far, and it was my final submission parameters. So things I tried but I didn't submit. I had a LLM judge. I was using Claude. At first I was using an API, but that was getting expensive, and I didn't really, fine-tune that method. Not fine-tune, but I didn't really spend time using the right prompt and analyzing the responses. So what I did is I would take a sample of 20 or 30 generations between two models, and I would structure a and B comparison prompt, and I would randomly put, actually not randomly, I would do one iteration where the first model is an A and second model is B, and then I would do the same thing, but I would flip it, and then I would give both to Claude and tell it, which one has won based on creativity, grammar, etc. And then it would give me a response, and I found that it was pretty correlated with the actual submission scoring. So my LLM judge plus manual inspection after training a tokenizer with the default initial vocab size and a minimum frequency of 128 on the full sample set resulted in a 14,000 vocab size. So that let me create a wider arc, and I had more non-embedding parameters. I also tried different generation parameters, but I found that it actually, did not perform well. And so it was, significantly inferior. Just reading through the stories, they were just not as good. They were nonsensical at times. Grammar was worse. So even though I, was really excited about the potential of using more parameters, non-embedding parameters because of the smaller vocab size, unfortunately, I was not able to achieve a quality tokenizer. Things I would have tried if I started earlier, I spent 11 or 12 days, and, we had about 4 weeks, and I started late, which, no excuses. That was a choice I made. And things I would have done if I had more time, I would have reread the TinyStories paper, which I did afterwards, and I have a video about that. I would have experimented with their learnings, their width-depth trade-offs, the number of attention heads, the hidden dimension size. I was planning to train a large class model, so I was doing all my experiments in the medium class for efficiency and to get in one submission every day. But I was kind of gearing up to do a final set of training runs for a large class model, but that never happened because I ran out of time, because I needed to spend time for inference parameter testing. I also wanted to train a small class model. The TinyStories paper has a 28 million parameter model, an 8 million parameter model, a 1 million, 3 million that generate coherent text. And I think there's nothing cooler than small models beating large models, so I really was hoping to have some time to do that. I would have copied the TinyStories model architecture and their tokenizer and experiment with that, train more tokenizers, try more hyperparameter sweeps with learning rates, epochs, weight decay values, come up with a more robust LLM judge that was better correlated with the actual competition judge, and implement eval during training for a sample of prompts so that I could get quicker signal before I wasted too much time and compute on the number of epochs. And then finally, there was an opportunity to try out different dataset mixes, cleaning the dataset, lots of work that can be done there. Even if I had the 4 weeks, things I wanted to learn and do, but I didn't have capacity to do that in the 4 weeks, are doing model surgery and writing a custom model. That's still something that is on my bucket list of things to do. Implementing sequence packing manually, well, not necessarily manually, but copying what modern BERT has done for my purposes. Implementing flash attention just as an exercise, that would be really fun to do and probably really challenging. Implementing QK layer norm and an auxiliary loss. These are two training instability mitigations from the small scale proxies paper, where they find that if you implement these two, then you can train on a learning rate that's like 1 or 2 orders of magnitude higher. And so that would have led to potentially faster training. Implementing a weights and biases callback, I think, is how you would do it to have a evaluation by the LLM judge during training and then log that score in weights and biases, and then training tiny models on various downstream tasks. That's not related to the hackathon competition, but that is just something that I want to learn and do. So here's a summary of my data prep and training. I used the Llama 2 7 billion HF tokenizer. I appended the EOS token and I pre-tokenized the dataset with this function that is shown here. And I'll go into a little more detail in a second. I used the Hugging Face Trainer, Google Colab Pro, a batch size of 384, gradient accumulation steps were 3, a learning rate of 5e-4, and weight decay of 0.1, as we saw by the TinyStories author. I used A100 40 gigabyte because I was planning to eventually graduate to a large class model, but that never happened. Flash Attention 2 with the data collator with flattening. I used Liger kernel. That definitely gave me an increase, I think like a 25% or more increase in terms of training speed. Torch compile did not work. I was getting some like flash forward error that I'd never resolved, so I kept that as false. And then I used Torch empty cache steps at 256, and this allowed me to train with a higher batch size. Every epoch I would push to Hugging Face Hub, and I use weights and biases for logging. And this is the final model that I created. The funny thing about this is that when I created this model, I was just throwing things at the wall and seeing what would stick. And it turned out that even though I tried different architecture values, I tried different scaling for the MLP, in and out features, I tried a different hidden dimension here, I tried different tokenizers. It ended up that this initial, just thing that I tried to slap together to try to get under 60 million parameters was the model architecture that performed the best. So unexpected, but that's how it goes sometimes with these competitions. So that's an overview of the competitions, kind of details. I'll do a quick walkthrough of my Colab notebook that I used for training. So installing, actually I don't think I ended up using Mosaic ML, so I think I can remove that. But installing datasets, flash attention, installing Liger kernel, so you can use the use Liger kernel parameter in the Hugging Face trainer. Oh, this is why I installed Composer, so I could use their reproducibility.seedall. Every time I loaded a tokenizer, I made sure I looked at the vocab size, the padding side, the BOS token, and the EOS token, and the pad token if there was. This was the configuration, the llama config that I used. And here's the hidden size, the intermediate size, number of hidden layers, number of attention heads, etc. I experimented a bit with these ones, but I could have done a lot more, especially if I considered a larger model. And printing out the number of parameters to make sure I'm not going above the weight class limit. And then I, just as a sanity check, I generated some text to make sure that it was truly a random architecture that was being loaded. Data prep, I'll show it in a different window in a second, but I would load my data set, so I tokenized it and I saved it on Hugging Face Hub. Every time I would make sure that the OS token and EOS token were present, both in terms of the tokens themselves and then also decoding the text to make sure that looks correct. Just doing some examples to look at the data, make sure it looks correct. I chose to use an eval set of 10,000. To be honest, because I was iterating so fast and I was kind of in, emergency mode the whole 11-day stretch, I didn't really pay attention to the eval loss. I didn't really pay attention to loss at all, other than just looking at it, making sure that it went down. So I just, picked 10,000 and stuck with it. And then weights and biases logging setup. And then here are my training arguments. So a couple of things I could have experimented with, training for more warm-up steps. This is another training stability best practice that I read about in the small scale proxies paper, where they recommended a longer number of warm-up steps. I also broke up the eval into 256 steps. I think it offloads it onto the CPU. I'm not 100% sure, but it was helping me keep my memory in check. Trained in BFC, and I think everything else for 20 epochs. And then for dataset tokenization, this was something that I wanted to be very clear and thorough that I was doing correctly. So I did a little bit of a dive into it. So this one here is without the EOS token. So I wanted to understand how is the BOS token set, and so I was going to mimic the same thing for the EOS token. And I found that the EOS token is token 1, but then it had this 29871, which turns out is an empty string. But when you combine it, so here is, and 259 is a space, but when you combine the 29871 token, the empty space, when you combine it with another token, it turns into a space. So here is 29931, which is L. Here is my end of sequence token, which is this one. And then here is not a space, but an empty string. And as soon as I put an empty string next to it, it turns into a space. So I don't know if that's common, or I don't even know if I'm quite understanding that correctly, but that was something I just wanted to make sure so I could replicate it. And so the rest of this is pretty straightforward. I make a function where I'm putting that empty string EOS token, and then I'm extending the attention mask to include ones for those two tokens. And then I'm using .map on the Hugging Face dataset, making sure it decodes correctly, doing some spot checking, and then again doing some more checks with start, the beginning and end of attention mask and input IDs for different dataset items, just making sure it all looks good. This took 20 minutes or so, but making sure that the first token is always the BOS token, the last token is the EOS token, and making sure that the attention mask is all ones, which was, everything was in consideration. And so that worked, and then I would push it to Hub, and, I stuck with that data set. So in summary, this was a really, really exciting experience for me. I'd never pre-trained a model before. I had never pre-trained a small model that generated coherent text with creativity, with plot, with coherence, with grammar. And so as you'll see in upcoming videos, this has really opened up an entire universe of research and implementation possibilities for me. So I'm excited to share what's coming up next for me in terms of projects that I'm putting into motion. So be on the lookout for a video on that. It'll be tiny models related, and I'm actually going to get that right after I record this video. So thanks again for watching, and I'll see you next time.